Today we continue our series on the ECG. This video is so important because we're gonna discuss the basic physiology of the ECG normal waves. In our previous video, we discussed the way that the ECG machine works. In this video, we're gonna look into the changes in electrical activity of the heart and how the ECG machine reads it. Before we continue, please don't forget to like, subscribe, and share the video with your classmates for more free medical contents. The electrical activity of the heart is initiated by the sinoatrial node. The SA node starts to fire and the action potential is transmitted through the gap junctions between the myocytes. So the action potential spreads from the SA node towards the whole cells of the two atria. Between the atria and the ventricles, there is a fibrous layer called the cardiac skeleton. It works as an insulator. We could say that the only way that electrical activity is transmitted from the atria to the ventricles is through the atrioventricular node. In this example, if we looked at the direction of the electrical current, we will see that it's going towards the positive electrode, meaning that the ECG machine will record it as a positive wave. This would be the first wave to appear in our ECG paper. It's called the P wave, and the P wave is caused by the atrial depolarization. From the atria, the electrical current is conducted through the AV node. The AV node, as mentioned in our previous video, that it is designed to slow down electrical current, giving more time for ventricular filling. The ECG machine will read a flat line during the time of which the electricity is conducted by the AV node. Electrical current is then conducted by the bundle of His, which is going to divide into the left bundle branch and the right bundle branch. From the left bundle branch, small Purkinje fibers innervates the septum of the heart. Septal depolarization is initiated from these fibers going upwards. And septal depolarization here is moving in a direction that is opposite to our positive electrode. It is read as a negative wave by the ECG machine, and this wave is called the Q wave. After the septal depolarization, the electrical current will reach the ventricles. Major ventricular depolarization takes place, and the electrical current is moving from the inner layer of the myocardium to the outer layers. So here we have an electrical current that is moving towards the positive electrode, and the ECG machine will record it as a positive wave, and this wave is called the R wave. At this point, most of the ventricles are depolarized, but there is a small area remaining at the base of the heart, and these are the last areas to be depolarized, the base of the ventricles. And the electrical current here is moving away from the positive electrode, and our ECG machine will record it as a negative wave, and this wave is called the S wave. Till now we have the QRS complex, Q wave for septal depolarization, R wave for major ventricular depolarization, and S wave for ventricular basal depolarization. At the time when the ventricle depolarization is going on, atrial repolarization is taking place. Repolarization is a negative electrical current moving towards the direction of the negative electrode, so the machine should read a positive wave. But because the ventricles are much thicker than the atria, the ECG machine could only record the larger wave, which is the ventricular one, and that's why atrial repolarization would never be recorded by the machine. After ventricular depolarization is over, we should enter the phase of ventricular repolarization. But as we mentioned in our previous video, that in the action potential of the myocytes, there is a plateau phase due to the opening of voltage-gated calcium channels with the voltage-gated potassium channels, delaying the repolarization phase. The plateau phase is recorded by the ECG machine as a flat line after the S wave, and after the plateau phase, we enter the repolarization phase. Ventricular repolarization starts at the last area that got depolarized. Repolarization is a negative electrical current moving towards the negative electrode. This would be read by our machine as a positive wave, and this wave is called the T wave. And now let's quickly revise all the normal waves that was recorded till now. P wave caused by the atrial depolarization, Q wave related to ventricular septal depolarization, R wave because of major ventricular depolarization, S wave related to ventricular basal depolarization, and T wave related to the ventricular repolarization. Also by now we know that we have two flat lines. First line is between the P wave and the Q wave, and it's because of the conduction delay by the AV node. And the second line is between the S wave and the T wave, and it's because of the plateau phase of the action potential. Sometimes an extra wave could appear due to the electrical activity of the papillary muscles, and it's called the U wave. Also we have something called the segments. We have the PR segment, and it's caused by the delay of the conduction by the AV node. Another segment is the ST segment, and it's the flat line that is due to the plateau phase, meaning the time between the ventricular depolarization and ventricular repolarization, and it's called the ST segment. And lastly, we take a quick look into the intervals. We have the PR interval, and it's the time between the initiation of atrial depolarization until the beginning of the QRS ventricular depolarization. We have the QRS interval, and it's the time between the Q wave till the S wave. There is also the QT interval, and it's the time interval between the beginning of ventricular depolarization till the ventricular repolarization. And that wraps up our part 2 video on our basic ECG series. In our next video, we will take a deeper look into the ECG paper and discuss important clinical notes. Thanks everyone for watching, and I will see you in our next video.